so many tabs have to be open. Okay, I think we're good. Group 16. Meeting. Yes, completed it. Okay, so I'm going to have to figure out why all the slices are different sizes.
Okay,
That's very basic. Okay.
yeah, hang on, let me see. That would be the second one.
Yes. I
It's more
agree.
visually appealing. I like that.
Yeah.
That is true.
It is. I agree.
Okay, how are bar charts and Pareto charts related?
The
The
difference.
last one, isn't it?
Yeah. Yep. The only difference is that you like rearrange the chart.
All right.
So I need to open the book back up. Let's see. Okay. So P with the little symbol above it is the where'd it go?
Is the P with I think it's a sample proportion because the P without the symbol over it is the true proportion. Because isn't the with the symbol over it the point estimate?
Yeah, I think that's so. So it's asking us if the P with the symbol over it is the true proportion to the sample proportion. It's the sample proportion. In this. Oh yes, because in the formula, we use the sample proportion. So I'm pretty sure that's it.
Well, I have in my notes it says P equals the true proportion. P without the symbol.
The sentence above it confuses me. So we conclude that P whatever is normally distributed.
Right.
So I guess
again.
I think you're right. I think it's probably just saying, plain P is the true proportion.
Right. All right. I'm just going to go over the notes real quick here. Just want to double check.
Yeah, I think sometimes the wording kills me because, I think I understand what each thing means, but then it's like, is it asking us just P or I'm overthinking it, I'm sure.
Yeah, well, there's examples where it says if the true proportion of people who support a particular political party is P equals, but it's the P. So if they're talking about true proportion and it says P, then I guess that's what it is. I don't understand the whole difference between, I honestly don't understand the difference between true proportion and sample proportion.
So the true proportion, well, it's just with the sample size, not the sample size. Try to think of the right word.
Like overall proportion versus just the people you sampled?
Well, because, okay, so when we were doing the other samples, we had the sample means, which was the X with a little bar over it. And so this is the same thing. So it's not the actual. Does that make sense?
Yes.
The same type of thing.
Okay. All right, so what is N? That's sample size.
Mm-mm.
No.
Well, the N is the whole proportion. Somewhere I saw it's number of successes. Let me... I know, it was weird, because normally I would think that it's that.
That's how it always was in the past. Okay, the number is the people surveyed, or the... Yeah, it would be the sample size, because in the examples it's talking about the number of people surveyed or whatever, and that's the number. So that's the number of people polled or the number of people sampled or used.
Where did I see that? See, I think I'm just making things up now. My brain's just
All
kind
getting
of.
old.
Oh man. Okay.
Okay, so if P is 1/4, what is the smallest n that satisfies the requirement? Well, you probably have to do the.
So it has to. It's the how large is large enough section.
Right.
But the formula is n times 1 minus p is greater than 10. And so if p is 0.25, what's the smallest? Okay. Needs to be greater than 10.
So if it's. Hang on.
Easy way to do this. I think my brain's just tired.
I don't know how to do. I don't know how to figure this, honestly. I mean, I see the formula for calculating the number, but we don't have any of the other information. We don't have the margin of error or the z-score or anything like that.
So I don't think we need that. I think we just, let's see. Okay, I need a piece of paper is what I need. Hold on. Let's see, let's scribble. Okay, finding the paper wasn't hard. Finding a pen might be another story. Oh, no. So it's n. So we greater than or equal to 10. Okay, so n is what we don't know.
Mm-hmm.
And we have 1 minus 0.25. That's p. Greater than or equal to 10. Okay, so I think we just need to do simple.
Well, if we're doing if it's 0.25 times 0.75, right?
Well, see, I'm looking at the just the n times the 1 minus p. So I'm not sure that it's the rest of the formula.
I'm just going to go through here.
The other formula is in lesson 17, but we're in lesson 16, so it makes me think it can't be that difficult. It has to be basic.
Okay, so here it says in 3.2.1, how large is large enough? Okay. Right. If p is very close to 0 or 1, then point estimate isn't close to normal unless n is very large. What does that mean, very large? Very large is in 30? Very large is in what?
As in the formula that gives us, it has to meet the requirements.
Yeah. Well, if it's only 1/4, then it's not large enough.
Well, it's asking us what the sample size would have to be.
Yeah. Okay, so n times p. Yeah, but we don't know that. I mean, So we have to figure out what times 1/4 is greater than 10.
I
Right?
think it's yeah. So 14. So what I did was 10 divided by 0.75, and I got 13 point something something. And so I rounded up. I always round up.
14 then?
I think so.
Well, but then if you take that and reverse it and do 14 times 0.25, it's not big enough.
No, but it's 1 minus 0.25 because it has to be the 1 minus sample size. Does that make sense?
Yeah. Well, okay, so it's there's two different things. N times p is greater than 10, and n times 1 minus p is greater than 10. So they both have to be satisfied. So I was looking at the top number going 13 times 0.25 is what I was thinking. Do you understand? Like,
yeah.
this top one has to apply as well.
So
I mean, that would be 40, sample of 40, if you're doing it that way.
oh, we probably should have taken the first one. So no, you're right. So yeah, so point. I mean, and then it does for sure qualify for the next one. Because then you have.
Well, if you get a sample size of 40 for the first one, it certainly qualifies for the second one.
Right.
So you'd have to have at least 40 to qualify for the first one.
I think you're right.
I don't know.
This is why I don't like. I understand following through the book, but when it does such random, different questions and doesn't allow us to redo the quiz,
Right.
killing my grade.
Yeah, I know.
Okay,
so number 8, what is the mean of point estimate? It isn't it the same? P equals P?
No, the mean is 0.4. Is that what you're saying?
Yeah.
Okay.
So P equals P, basically. What do they call it? Point estimate versus true proportion, right?
Yeah.
Okay, so in my notes I have that. P equals P, basically. The mean of P equals the mean of P.
Yep.
Okay. Just checking. All right, so what is the standard deviation?
P, which is 0.4, and N, which is 4. I'm going to square root that. So I got 0.004.
Hang on, let me just try this real quick. Okay, so hang on a second. 0.4 times... I got 0.01.
You have to square root it. Did you square root it?
Oh, no, that would help, wouldn't it? Hang on. .1? I'm on my phone calculator. That's the problem I have.
Well, I think I did it wrong, too. So.
You got .1 too?
No, I did it wrong. This is what I'm saying. Oh, no, that's right. Point 1 is right. Yeah, I did it wrong.
Okay. All right, so use the following information to answer. Brittany's batting average is .300. We want to determine the probability she will get more than 35 hits in her next 100 at bats.
Okay, so P. Okay. I didn't come up enough. Just here. Kennedy would be the same.
So P equals X over N.
That's P.
The point estimate equals X over N. So if we have 0.300 divided by 100, that would be 0.003.
Oh, isn't it? I thought it was giving it to me. Not. So the true proportion is C. So for point estimate.
The formula for point estimate is X over N.
Right.
So I'm guessing the X is the 0.300 average.
No, I think it's the 35. Because it wants to know if she's going to get more than 35 hits. So let me look back to the example. I don't know why I always do. I don't like it.
Huh. Well, makes more sense. So 0.35?
I think so. I'm trying to find the explanation exactly.
Okay.
Okay, here we go. So in 3.1, yeah, there's a working
Which section? 3.1?
3.1. So it's a proportion of head cost. So
Okay.
sample proportion for R is 0.3.
Mm-hmm.
But it wants to know ability. Maybe this is example.
Okay, so here 3.3.1. Observe 13.
So are we saying the point estimate is
Sorry, you're cutting out.
Are we saying that the point estimate is 0.35?
Well, yeah, but I wasn't sure if we're going to use the number 35 or if we're going to use 0.300. Because we're trying to find out if the probability is greater than 35. So I thought we would use the batting average of 0.300 in the equation.
Okay, so on the probability estimate, number 9, we have to do something kind of like this. So I'm going to look at it again.
Okay.
Okay, we want the point 3 we know that her batting average is 0.300.
Right.
And so the point estimate is going to be the one that wants 1.5. So it's 35.35. I'm pretty sure. So then the standard deviation is easy to find.
So we're using the number 35 in the equation then instead of the 0.300.
Because 0.300 is the true population. We know that.
Okay.
But that's the point estimate, which we know.
Okay. All right, so 0.35 then.
Yes.
Okay.
Standard deviation would be 5.
So that's going to be P times 1 minus P.
At the end.
So
we're going to square root that.
I got 0.046.
I got 0.047. Did you round before you finished?
I may have. No, hang on a second. So hang on. So it's 0.300 times.
No,
Sorry, 1 minus 0.300.
0.35 though. We're not using 0.300.
Well, we're using not 0.35 because P is 0.3. Point estimate is 0.35.
Right, but it wants. Oh wait.
So we're trying to do the standard deviation of point estimate.
Wait a second.
And that formula is
No, you're right. See, this is why I did this group. We would always do that.
Yeah.
It's one of us right.
Yeah. Because the square root of P times 1 minus P divided by N.
You're totally right. I got 0.4. I mean,
Yeah.
0.6.
Yeah, 0.046, yeah.
Yeah.
Okay, and then the z-score is the point estimate minus the true proportion, or whatever what is that, true proportion? Divided by the square root of the standard deviation. Or divided by the standard deviation.
So you're right. The point estimate minus true proportion.
Okay.
Bye.
Wait a minute. Okay. 0.35 minus 0.3 divided by 0.046. I got 1.087.
Okay, I'm almost there.
Okay.
Just entering it into my calculator, making sure I have all of the necessary parentheses. I missed a parenthesis.
Why is it that it's not showing me the probability app now? Doggone it.
So what did you get?
Hang on. I got 1.087.
I got 1.91. I mean 1.091.
Okay, so let me just go over the formula. I got 0.046 minus 0.3.
The point estimate. Oh, wait. Oh, I did it wrong. Oh, I don't know where my brain is. Sorry about that.
All right.
No, I never mind. The point estimate is 5. Right, so it's 5 minus
0.3.
Which ends up being
0.05.
Right. Oh, I think what happened, you just used the standard deviation, right? You put it in the calculator.
Oh, wait a minute. Hang on a second. Let me just double check that.
Okay.
The value, yeah. So 0.35 minus 0.3 divided by the standard deviation of 0.046.
Right, but the problem with 0.046 is that we round it. So we have to put the actual numbers back in.
Well, that's stupid.
An accurate I know. I stupid.
Okay, well, what was it? 0.04.
I lost it. I'm doing it again. Okay, I got the z-score as 1.091. Rounding.
You know what? I'm gonna stick with it the way it was, just because they're asking for the individual information, and then they're asking for it to. I don't know. So what do you get for the probability then? We just put the z-score in and shade the center on the normal probability app?
Not the center, it's right. We're putting the z, and we want the probability
to be at least 35, right? It's not asking for greater than.
So it's the center and the side.
That's right, and the right side. So point, yeah, okay. So the center and the right part.
Okay, I don't know how to probability app. I think that one now opened again. So I got 6, 2, 4. But if you're not using the z-score, it's going to be different.
Yeah. Well, you put in yours, I'll put in mine. We'll just see. I'm willing to take a chance. I just don't want to overcomplicate, you know? And I think what he does is sometimes when you miss him, he'll go back and figure out how you missed him, and he tends to let you off if the rounding is slightly off. At least that's what he says in the meeting. He's like, I'll go through each question individually, and if it's because you rounded before or after, then I'll change it, you know, that kind of stuff.
Mm-hmm.
He doesn't seem to be too concerned about it.
Right. Well, because I know in the book, don't round at the last moment. And so if we rounded for the answer for standard deviation, fine. But when we want to, you know, it's not what we can do.
Right. Okay, so number 14, we go back to doing the same formula, p times 1 minus p divided by, and the square root. That's right. Okay, so 1 minus 0.52 times 0.52 divided by 2,000 square root.
I mean, let's see. I keep forgetting what the is. I got 0.011.
0.011?
Yeah.
Yeah, that's what I got too. Okay, so now they're asking for the z-score, so we got to go back and get the point estimate. We have to know what the point estimate is before we can do the z-score. So the point estimate is x divided by n.
But we don't have it.
We don't have x.
Oh, when you don't have, well, let's see. Let me see. Oh, the z-score is for the, it's an example 3.2.
Wait, what?
Point two.
How'd you get that?
Sorry, it's the last example for the summary of chapter 16.
Hang on. I lost my main page here.
Oh, never mind. It doesn't help if you still have the z-score, the point estimate.
Okay, I guess I'm totally lost. I just lost everything. Hang on a second.
Oh no.
I don't want to pull it all back up. Okay, so just tell me, okay, in order to do the z-score, we have to have the point estimate, which we don't have.
As far as I can tell, unless there's a way to figure it out, but I'm
Well, in order to find the point estimate, we have to have x divided by n. We don't have an x.
Someplace talks about next.
Well, I don't know.
Maybe. It's giving it. We have the solution. Oh my god. The P is the same, isn't it? Because
Well, the true mean of the mean are the same, right? If the mean of p is the mean of point estimate. But maybe it is the same. I mean, maybe that's what they're saying.
yeah, so I'm not sure what I.
But then that would be zero. Yeah, that's not working out.
And then it's just the deviation.
I'm gonna try something here. Hang on.
Oh my gosh, we can just use it. It explains the 3.1.
3.3.1?
Yeah.
Hang on. 3.3.1. Okay. So, well, in that one, they're given the point estimate.
I was trying to. Well, because it says simply substitute. No. And I was on. Well, we've done this in past lessons when we haven't had a value.
Yeah, I don't know how we did that. Did we just eliminate that? Is it just P divided by...
I think we just used the top part. I think we just used the bottom denominator.
Yeah.
Denominator. Oh my gosh.
But that would give us 0.00026.
Very. Oh. Well, no.
Yeah, that's not gonna work.
Who's calling? And I'm going to give minutes to pick out. Okay. My brain to work. It's not that hard. Like, it shouldn't be.
I know, right?
I think part of us, we don't know what we're doing.
Yeah. Just not seeing anything in this lesson about it.
The true people. I think it is divided by the standard deviation.
Right, but that ends up giving us a 0.52 divided by the standard deviation. So, no. If we do P divided by the standard deviation, that gives us a z-score of like 47.
Okay, let me see.
Oh no, it's 4.72. That's still high though. No, that's right. 0.52 divided by 0.011. Yeah, that's way too high. That's like 47.
Okay, hold on. Wait a second. Do that.
Hang on a second. I think I may have found something.
Okay.
And example 3.3.2, they're giving us the same kind of information. In fact, it's the exact same question, I believe.
Okay, so
because they're using the 50%. That's the point estimate is 50%, so 0.5.
oh my god.
Right?
Yes.
Okay.
Right in front of our faces. I knew it was right in front of our faces.
I know. Okay, so okay, we got to do this again. So 0.5. All right, and we are doing the 50%. So 0.5 minus 0.52 divided by 2,000. Wait, whoa, what am I doing here?
That's definitely not going to get you what you need.
All right. Okay, so 0.5 minus 0.52 divided by 0.011. No, 0.5 minus 0.52 divided by 1.818.
Okay, give me a second.
Okay, what'd you get for that? Did you figure that out?
I'm almost there. My brain is working so slow today. I got negative 1.79.
I got negative 1.818.
Rounding again, I think.
Okay, so I just did 0.5 minus 0.52 divided by 0.011.
Yeah, I did the equation again.
Okay. I didn't round. Oh, because you got the standard. Oh, you did it again. I see what you're saying. Okay, that's fine. Let's see.
So what probability do you compute using the normal probability outlet?
It's going to be less than. It's going to be the bottom one. Because if you plug in that z-score, you're getting like a 0.0345 probability, and so that's less than that's less than 50%. So the probability of it being less than 50%, that's going to be the bottom one.
So the z-score is the lowercase c, though, right? Well, I don't understand. Okay, I don't understand why there's a.
But if you look at the example 3.3.2, it says they came up with the probability of 0.0982.
Uh-huh.
Hang on a second. Let me look at that again. Because we're finding out less than 50%. We're looking for less than 50%. So we're going to go to
Right.
the less
I just
than.
don't. I don't get the capital Z and the lowercase z.
I
Because
know.
what is it supposed to represent?
Um, not showing that. It's showing it as capital P and lower p, or probability and point estimate. It's not showing Z and Z.
Yeah, I don't get that.
I don't either. Hang on. I'm going to scroll up, see if what I can find. Yep. So it's the probability times the Z-score is less than the Z-score? Is that what they're asking? Or greater than the Z-score?
No, I don't know.
5 times.
I almost don't care. Well, let's just pick one.
Is
We can go with the second one. That's fine.
okay. All right. What is the probability the survey results will show the Canada's losing? So I got 0.035.
What were you shading? Because shouldn't it be to the
Left.
middle and the left, though?
Well, they're asking for less than 50%.
Oh, and 50% is what we calculated. So it's, yeah, I think you're right. So it's 0.0367. Is that what you got?
Well, again, the rounding. I end up getting 0.035 when I rounded.
Okay.
Okay. That's it. I'm submitting. Don't submit yet.
Okay.
Okay, number 13. You probably had that right. I got that one wrong. I don't know. I had 0.862.
That's what I got too.
Okay, and then on the Z-score I got negative 1.818. I got that one wrong.
Okay, so 0.3. Okay, that's confusing. Can you meet again in like an hour for the second session? Because I need to go pick up Alec.
Yeah, that's fine.
Okay.
We'll see you then.
I'm good.